Find the following limits. So as x tends to 1, this will be simply 2 lots of 1 plus 3, won't it? Which is equal to 5. So at 10 to 5. Here we put 2 in, 1 plus 2 lots of 2 plus 2 squared. 4, 8, 9. Here as x tends to 3, we'll have 1 over 0. You can't divide by 0, so it's not defined. Because you can't have 1 over 0. It's not going to be a value, is it? So that's no good at all, because there's no way of simplifying that. But in this case, we can simplify this one, because the top is, well, let's just write lim again. X tends to 2. And I know you get 0 over 0 this time. But as x tends to 2 then, let's have a look at this. Because we can use algebra in this case. We couldn't use algebra there because that was just 1 over 0. But here, the top is x minus 2x plus 2, isn't it? And then x minus 2 underneath. So here, the x minus 2's can cancel. And we can see that it's the limit as x tends to 2 of x plus 2. And that will be 4. So as x tends to 2, it gets very, very, very close to 2. This will have the value 4. This one, on the other hand, if you look back at it, if you put in 3.1, you'd get 1 over 0.1 is 10. If you put 3.01 here, you get 100. If you put 3.001, you'd get 1000. So it shoots off to infinity one side, but if you put 2.9 in, you'll get minus 10. 2.9 minus 2 is minus 0.1, and 1 over minus 0.1 is minus 10. If you put 2.99 in, you get minus 100. And then so on and so forth. So it shoots off in one direction up to infinity, and then down to minus infinity. So it's shooting off to either plus infinity or minus infinity, depending on which way you go approach 3 from below or above. So as we said, 1 over 0 is just not defined, and you can't simplify it. This one, it was 0 over 0, but you could simplify it with the algebra, and then this is much easier to deal with, because as you look at x tending to 2, it's going to stabilize at 4. This wasn't stabilizing at all, was it? Okay, so x tends to infinity. This looks tricky, because this will tend to infinity and this will tend to infinity. So we need to use algebra here. But the trick, this is a trick, so I don't expect you to see it, so I'll just have a look at it. If you write that as half, do some division of 4x minus 2. See it? That's 4x minus 2. Okay, and that will give you the 2x minus 1 on top, wouldn't it? But we don't want that. We want 4x plus 1. So if I write the minus 2 as plus 1 minus 3, okay, over 4x plus 1. So I've just done a bit of algebra. I've written 2x minus 1 as half of 4x, which will give us the 2x, and 1 minus 3 is minus 2 times 2 is minus 1. So I hope you can see I've rearranged this like this. The reason I've done that is so I can basically do some long division with the fraction, because I can now write this using the algebra as equal to the lim as x tends to infinity over half of 4x plus 1 minus a half of 3 is 3 over 2 over, so I've just expanded the bracket, half of these two, put in the bracket, minus 3 over 2 over 4x plus 1. So that's the algebra done. That was the trick. So this would be the limit as x tends to infinity. This now cancels. If you split up this fraction, it will just give you a half minus 3 over 2 over 4, because it's 3 over 2, no, over 2, sorry, of 4x plus 1. And that's what we've got. So I've used algebra and I've written this thing here in this way. And now instead of getting infinity over infinity and wondering what it's going to equal, if you look at it now, as x tends to infinity, this bottom bit tends to infinity. 3 over infinity is going to be very, very small, negative, so it's just going to be just under a half. So the limit value will be a half. This one we need to expand this bracket, and I'm going to give you that. I'm not going to do it algebraically, I'll leave you as a little exercise. So this is the limit as h tends to 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed over h, which equals the lim. Okay, so the x cubes cancel, and you'll notice there's an h common on top, so I can pull that out, and inside the bracket we'll have 3x squared plus 3xh plus h squared over h. And they cancel. Now, and we're just left with, as h tends to 0, this will be 0 times something as 0. This is 0 squared, which is 0. We're just left with 3x squared. So the derivative of x cubed, that's the definition, is 3x squared, as we thought. Now we'll come back to this question then. Find the gradient of sine x at x equals, so dy dx is equal to cos x, sine differentiates to cos on our table, standard derivatives. Find the gradient at x equals pi over 3, so at x equals pi over 3 then, dy dx is cosine of pi over 3. Cosine 60 is a half. Tap it in the calculator, you'll get a half. At what point is the gradient 0? So when does the gradient equal 0? So the gradient is cos x. When does that equal 0? That's a trig equation we've done. CAST. We're using radians now in this problem. So cos is positive when it's 0, isn't it? And we draw two lines. Mark off alpha. We write cosine alpha equals 0. Shift cos of 0 is 0. Shift cos of 0? Oh, hang on. Oh no. No, it's not 0, is it? Cos of alpha is 0. Alpha is 90. Shift cos... Yeah, cos alpha is... Tap it in, you'll get 90 degrees or pi over 2. Shift cos 0. Let's go into radians. Number 4, and it's shift cos 0, which is pi over 2, 90 degrees. So there's our solution, and these two lines meet here at pi over 2. So the solutions then, if we go around, is pi over 2, and we could just keep going around, and then round again, 5 pi over 2, that was round another 2 pi, and then 9 pi over 2, and we could just keep going and get all the solutions here. So that's when the gradient is oh yeah, I think that's right. Oh, 3 pi over 2 as well. Is it? Yeah. Alpha is 90. Oh, cos is positive here and here, isn't it? So that line wasn't there, it was here. And then we get another one here and here then, don't we, when alpha is 90. So we'd have to come around to here as well, so we'll get 3 pi over 2. And 7 pi over 2 as well. Apologies for that. And 11 pi over 2. I was thinking of the sine being positive, it's the cosine, isn't it? So that's that one. Now let's look at cos is 1. So when is cos x equal to 1? Let's try and do this one a little bit better, shall we? St, cos is positive. So cos is positive here and here. Draw off two lines. Mark alpha. Cosine alpha equals 1. Shift cos 1 is 0 degrees, or 0 radians. So we got 0. So those two lines meet there. So our first answer for x is equal to 0. Then we go around a full circle to 2 pi. Then we go around another full circle to 4 pi, and so on. And that's the solutions there. So apologies for the first one. The cosine is positive here and here, isn't it? Alpha is pi over 2, so you end up with that picture, word picture, and that one. And then you go round to here. That's the first solution, round here to the second, right round here to the third, round here to the fourth, and there they all are there. You can just keep going however many turns you want. That's the complete solution set.